Welcome to the Real Python Podcast. This is episode 217. What are the best practices for organizing data analysis projects in Python? And what are the advantages of a more package-centric approach to data science? Christopher Trudeau is back on the show this week, bringing another batch of PyCoders Weekly articles and projects. We discuss Joshua Cook's recent article, How I Use Python to Organize My Data Analyses. The article covers how his process for building analysis projects has evolved and now incorporates modern Python packaging techniques. Christopher shares his recent video course on grouping real-world data with pandas. The course offers a quick refresher before digging into how to use pandas group by to manipulate, transform, and summarize data. We also share several other articles and projects from the Python community, including a news roundup, working with JSON data in Python, running an async I/O event loop in a separate thread, knowing the why behind a system's code, a retro game engine for Python, and a project for vendorizing packages. This episode is sponsored by Mailtrap, an email delivery platform that developers love. Try for free at mailtrap.io. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Christopher, welcome back.
Hi there.
We are deep in the summer. What's interesting is we do have some news, a lot related to releases, which has been our trend, but a couple new items. So that might be interesting. You want to dig into the news here?
Yeah, August is usually slow, and I guess this is just the universe's way of reminding me that I'm wrong frequently. My bold claims in episode 215 that there was nothing to say, well, here we are. The first bit was an interesting little blip. You're probably aware that the packaging space has been trying to move away from the setup.py script used as part of setup tools for building, testing, and installing packages. Generally, this is a good idea. You shouldn't have to run code just to find out what's inside of a package. The movement started towards the use of setup.config files, and now with more recent tools, you're using things like pyproject.toml instead. So the setup tools library has deprecated the test command as part of moving away from command line use of setup.py. That was 7 years ago. Last week, they issued a new release with the command removed. Deprecated or not, the use of setup test is still in use by a lot of libraries, so wads of builds started to break, and the package maintainers were responsive to the outcry and immediately issued a new release with the test command put back in. So there was like a 2-day window if you had downloaded the new version that you would run into trouble. No word on when this is going to actually be turned off. And in fact, this is one of the reasons I moved from Tox to Nox, because the hooks in Nox allowed me to not have to use this, that everything kept telling me was deprecated. So, yeah.
So people have been seeing the warning for a while.
Oh, yeah. So every time I run Tox, it screams at me that you shouldn't do it that way, because that was how my Tox hook. And I'm sure there's a correct way to do it with Tox. Tox is very configurable, and that makes it a little hard for folks like me who use it casually. It's always like, wait a second, how do I do this? And I had it working the way I knew how to make it work. And sure enough, it's the deprecated way. The other odd thing about this, because it was only like a 2-day thing, there were like little bits and pieces of news, but there was only one space where I found that actually talked about the whole thing.
Right.
And it was
our buddy.
Bytecode's monthly wrap-up newsletter. It's kind of funny. I find, like, the story kind of summarizes the state of packaging in Python, right? 2 steps forward, 2 steps back, or maybe two steps and a half forward. We're inching there, but it ain't happening fast.
Yeah.
The next bit of news is the creation of PEP 751, which is a file format to list Python dependencies for installation reproducibility. If you've ever done pip freeze and stuck the results in a requirements.txt file, that's what this PEP is talking about. There are a whole bunch of packaging tools, speaking of packaging tools and the mess that is Python, and many of them have their own locking formats to describe the state of installed packages. This PEP proposes a new standard with the long-term view that all tools adopt it so that we're consistent across packaging tools. The proposal uses a TOML-based format, which goes nicely with pyproject.toml, and the new lock file would be called pylock.toml, with the addition of being able to stick something after it, so you can say pylock-bailey.toml if you need to specialize it, for example.
Okay.
So you can get your own lock file.
Okay. So this is going to go a little bit further than you might see in a pip freeze.
Oh, it's a lot further than what you see in a pip freeze. It's a lot closer to the feature list that Poetry has. So the format includes information on the version of the format of the file you're using so that they can future-proof it, a hash of the packages
There you go.
to see if things have changed, lists of dependencies, which is what you usually have in that pip freeze requirements.txt, lists of lists for either file or package locks or both. Then there's like metadata about them. So like this particular lock only applies if Python is of this version and all that kind of good stuff. So it's very, very robust. He's basically taken everything that they've learned out of, other packages and the problems they're trying to solve and trying to standardize it.
Cool.
So it's great. I'm all for standardization. And this is a step in the right direction. The history of packaging in Python makes me a little,
and even lock files. Yeah.
Lock files makes me a little dubious about this. So, the real question will be, will we see this implemented by most of the tools before, say, the heat death of the universe? So what can I say? The humidity in August makes me optimistic. So we'll see what happens.
All right.
And then, as you hinted, we've got a boatload of release information on the Python side. 3.13 release candidate 1 is out, and October is coming.
Time to test.
Along with a bug fix, which is 3.12.5, so just your usual maintenance release. On the Django side, 5.1 went from release candidate to full-blown release, and they accompanied it by 2 security releases, 5.08 and 4.2.15. These fix a couple of denial of service gaps and, more importantly, an SQL injection vulnerability. So if you're on the Django side, you should update. Like I said, not the typical news week in August.
Yeah, no. Yeah, we've got a lot of stuff to kind of cover. That's great. Moving into topics this week, this one fits in nicely to talk about packaging and making sure your code is ready for reuse in different places. This is a blog post that's by Joshua Cook, PhD. He works as a computational genomics research scientist. His piece is titled, How I Use Python to Organize My Data Analyses. He describes this as kind of the organization of projects and how it's evolved over like the last 7 years. So we talk very often about packaging and as a kind of an end goal to get something maybe to share with others. This is definitely more geared for his own projects. I'll just read the first quote from the piece. I need to perform interactive analyses in notebooks, execute command line tools, submit jobs to a high-performance computing cluster, or HPC, and anything else required to get answers to questions my team needs to advance a work stream. These projects and analyses have to move around sometimes. And so the idea of having all of the materials, all the different packaging needs to go with it. And so I think this is a unique case, but I feel like data science, this is more in that alignment. There's a lot of similarities there. And so I think people could probably pull some nice stuff out of this article. His system centers around creating and developing a Python package within each of this sort of analysis project. Each one of these projects gets its own Python package that's developed and used during that process. He uses the Mamba ecosystem, and there's a micro Mamba. And so it's a way for creating like virtual environments and managing your packages. He has some very specific things about naming. He suggests that maybe you develop your own naming methodology for packages. His, in this case, is about fly fishing and fly, tie patterns. He used to use a packaging tool called Flit, but since has moved on toward using the PyProject TOML method. This is something that we've discussed a few times in the show. In fact, we just kind of talked about it, how it's kind of a more modern way of doing packaging. And we had a really nice video course / code conversation with Gerarna and Ian that you can check out. In fact, the complete thing's on YouTube if you're interested and you're not a subscriber and want to get an idea of some of the really great content out there. It's a great introduction to, well, how can I build a package as I'm working on it? So he digs into the details about creating the PyProject TOML, what the file kind of looks like, and then basically you sort of install it on your computer. And during that install, you make sure to note that with a flag that it's editable. He includes lots of the other things you need inside there. He has a specific style for the plots that he uses, which is something that we've talked about before. That's a feature of Matplotlib, that you can have your own specific style for a particular project or analysis in this case. He describes building the code into modules and lots of best practices there. In the end, he ends up building a CLI using Typer. He has a few other best practices to share, which I think is kind of interesting. He has a module for all the paths that he uses for, say, the data files that he's accessing, output paths for where things are going to get rendered or saved, and other standard directories. And I would imagine that would vary, especially in sort of a university situation. You might have these very standardized places that need to be organized of how him and his team are going to work. Or even in your own situation, it's nice to have some sort of standards there and not have to create the paths on the fly for every project. So I think that's a neat idea. He's a big fan of enums for his projects. Enums can really be useful for consistency. We have a couple different articles, and I'll include some links for that about using them inside of Python. He talks about a few dry, don't repeat yourself concepts that he likes. Talks about reducing coupling and having the separation of concerns. He's a big fan of type hints. This is where my co-host grumbles. He wraps up by sharing some best practices he has about Jupyter Notebooks, including a numbering system that I think is really nice. And I'm definitely a fan of. This is something that, just as a media person working on a computer, don't number your file starting with just like a single digit or 2 digits. If it's going to get into the hundreds, start with 3 digits to begin with. It's really going to help you as far as sorting and finding things and working with it. And so anyway, I found it a really interesting journey into the best practices from a data science sort of space and strategies that work across Python development that I feel like could be used on either side of that. I think it's cool. I feel like, the different communities that use Python can learn a lot from each other. I feel like some of these ideas were also kind of brought up when I had Parsa on to talk about bioinformatics and using Python in the laboratory. So that was episode 197, something else you can kind of check out to continue.
Yeah, it's why I actually kind of like articles like this one. Like, even, I don't use Condor or its derivatives. So, it's like, okay. But it allows you to sort of see what other problems are people trying to solve and what else is out there and why are you making these kinds of decisions. And it helps you as you're thinking about your own as to, how you tackle things. And I find with this kind of stuff, there's often there's some little nugget in there that you never would have thought of because you don't think in that space. And there's that little piece of gold that you can steal and use for yourself.
That path one was one of the ones for me. I think that's kind of a cool idea that you could just make it a module that you can reuse, or even just think about that idea of like, oh, I should have a systematic way of doing this.
Yeah, exactly. Yeah.
This episode is sponsored by Mailtrap, an email delivery platform that developers love. An email sending solution with industry-best analytics, SMTP, and email API, along with SDKs for major programming languages and 24/7 human support. Try it out for free at mailtrap.io. That's mailtrap.io. What's your first one?
I've got actually one of my own courses this week from RealPython. It's called Pandas Group By, Grouping Real-World Data in Python. If you've never played with Pandas before, it's a data manipulation tool that uses a table format. Think of it like a spreadsheet, having rows and columns. Panda is built on top of NumPy and has a lot of the same concepts where you can do a single operation on a column or a row and then have that operation happen across every piece of data in that column or row. And the table format that Pandas uses is called a data frame. Where a data frame is a little different from a spreadsheet is that each row has an index name. And this is kind of like a dictionary key. So you can generate your own keys. For example, if you've got time series data, you can have the index be the timestamp. You can also have Pandas generate the key for you using an increasing integer. Indexes tend to trip up folks new to Pandas, as Pandas uses square brackets to access parts. And it looks a bit like a list slice, but in fact, it's closer to being a dictionary key access. And this can be a bit confusing, especially when the default index is a number, which makes you think it's a list access. So you think you're slicing and you aren't, and then you are. And yeah, anyways. So the data frame supports a concept called a group by operation, hence the title of the course. And this is similar to group by in SQL, if you've ever used that. It allows you to query the data frame, returning a new data frame where rows which are alike have been grouped together. You then typically apply some sort of operation on the groupings. This is known as the split, apply, combine pattern. You split the data into groups based on some criteria. You apply a function to each group, and then you combine the results into a new data structure. So let's say your data was shirts that you sold in a store. Each row would have the name of the product, some style information, say whether or not there's a collar on it, and a price. And if you wanted to do some calculations only on collar shirts, you'd group by the style attribute with a qualifier saying collared. And then for some insane reason, you wanted the average price of these, you'd then apply a mean aggregate, which then combines your results and gives you the answers. So the course is meant for folks who have some familiarity with Pandas already, but it does do a review first. So if you're a little rusty, you don't have to come in cold. It shows how to do a basic grouping, then different kinds of operations that you can perform as part of this split, apply, combine. Then it goes on to work with different ways of deriving groups, like using lambdas or the lock, ilock mechanisms built into Pandas. And finally, spend some time talking about the performance trade-offs of the different approaches and why you might pick one versus the other. So this is normally the part in the summary where I wrap up and say good things. But since it's one of my courses, I'll let you say good things. Compliment my work, please. I desperately need validation.
Well, I found it interesting that this is kind of one of your first delves into the, I don't know, I want to call it the data science side, but Pandas is used in many, many areas, financial and so forth. But it was sort of new to you and you felt a need that, gosh, it would be really good that people had a refresher here. So I like that you went out of your way to build that information in to make sure that people would have, that could take the course without necessarily having to dive deep into lots of other Pandas courses to get into it. And indexes is one of the weirdest things in Pandas, honestly. And I think it's interesting that there's this, I don't even want to call it a debate. The Polars guys are like, you don't need indexes.
Right.
Here, I'll prove it.
Yeah.
And they just use them in a very, very interesting way here. And I think it's sort of fascinating that's such it's something you should know about if you're going to use it, because it's there.
Yeah, and that was part of why I was thinking the review was sort of necessary. I was worried that because Pandas is such a broad library that somebody might even think they use it routinely, and then maybe they don't touch ilock. Yeah. And then I go to show the ilock example, and then you'd be like, wait,
what?
How is it doing that? So
yeah.
I figured even for folks that, and if you're an expert, skip that lesson. Making sure that you sort of touched on, hey, here are all the concepts before you go and make them really, really messy by trying to use them to filter and then, take the groupings of one data frame and applying that to another data frame because the indexes are in common. You better understand how the index works, or that's just going to lose you, right? So, yeah,
you do some really interesting stuff in some upcoming courses that people get to kind of check out, where you're able to do very, very complicated things in those accessors, if you want to call it that.
Yes.
Where you can kind of have logic or sort of a statement inside of that's going to do something, which is kind of cool. And so this is a nice introduction to that, I think, in some ways. And group by is, one of the powerful things and why people were excited for, Python and Excel and things like that. It's like some powerful things that they've been using inside of Pandas to be able to apply that across lots and lots of rows and numbers and things. So
yeah, I think you're hinting at the upcoming astrophysics course.
Yes.
And I wrote that in conjunction with a student of astrophysics. And I mean this with all love and respect. He wrote code like a physicist, and so he'd solve the problem, and then I would take it and cut it by about a third. And often, how I got it down from 200 lines to 50 lines was, oh well, that loop you're doing, that's a single line in Pandas, right? So it takes a little to wrap your head around it, but once you got it going, it's a very, very powerful mechanism.
That would be a fun, I don't know, seminar or meetup or something like that. Have a bunch of data scientists meet with a bunch of computer scientists and say, let's just talk for a minute. Well, what are you doing here? As long as everybody's open-minded about it, and it's not in an insulting way, but that would be kind of a fun thing.
Yeah.
So my next one is sort of this explainer that is a bit of an update. Philip Ixeni took this article that existed on the site, and we do this fairly often. We refresh things and update them to make sure that the versions are solid, or maybe we're updating the language and so forth. It's titled Working with JSON Data in Python. And so it's one of these sort of fundamental things that if you're going to go through, like I've mentioned a few times recently, we talk about APIs all the time. If you're going to work with data and do stuff with APIs on the internet, then you're most likely going to be sending and receiving JSON formatted stuff. That's just a common thing. It's a really popular way and format for doing that. JSON stands for JavaScript Object Notation. I call it JSON instead of JSON. I don't care. You can pronounce it however you want, but that's just been my way of saying it. The article really digs into kind of the differences, things that you're familiar with inside of Python that this sort of looks like. You might say, oh, hey, that just looks like a dictionary. And it's like, well, okay, yeah, it has probably a very, very similar idea. There's keys and there's values and the way things are structured. But the syntax is actually kind of unique. There's subtle differences, and that's why this is here as a resource for you. The data types are slightly different in JavaScript. And so the things that are in the JSON, things like integers and floats, are numbers. Both of them are numbers, which is an interesting thing. True and false, you're used to the idea of maybe capitalizing the first letter of both of those in Python. They're not capitalized like that. Inside of JSON, the none value is a null, and so on. So small differences, stuff to watch out for. So this is the idea to kind of get you familiarized with it. There's some other kind of not typical things that maybe people are used to. I don't know how often you would do this, but comments are not allowed in a standard JSON file. Things that you might have done, like having a trailing comma inside of certain things, it will not like that. Things that you're used to, like arrays or lists in our case, dictionaries. Philip mentions a couple versions of JSON that are out there that do allow more flexibility. I'll let you do more research on them if you want. One is abbreviated HJSON or human JSON. The other is JSON-C, which is JSON with comments in it. So he talks a little bit about that, shows you some examples. The tutorial covers the whole idea of converting Python dictionaries into JSON and gives you some code for that, serializing other Python data types into JSON, and then fundamental stuff like you need to be able to read and write this stuff. And so there's the built-in JSON library, and maybe you've seen these terms before. Methods come up of JSON.dumps or JSON.loads, and talks about using both those things. And then a couple other kind of areas where it's pretty common that you get this large amount of data back, and then you want to look at it, and it's just this huge blob of data. And so ways to prettify that output so it's more understandable and readable in things like the terminal, and then also a few techniques for validating that, hey, is this proper JSON in the terminal also? So fairly common thing if you're going to be doing web development or working with APIs. This is a concept that you want to be familiar with. And then another thing that is briefly covered at the very end is many web developers know this idea of that, hey, let's make everything as small as possible. This idea of minifying, and that you might do for CSS or for your HTML. Minifying the JSON data is something else that you can do. And so that covers it. So again, just another really useful resource to get you up to speed with working with it inside of Python.
So I also pronounce it JSON.
Okay.
But it's not dumps and loads. It's dump S and load S.
I know.
The S is for string.
But it's just fun to say dumps.
While we're doing pedantic word games.
Well, there is the just JSON.dump.
That's why I've always pronounced the S separately rather than the plural. It's not something I talk about out loud, so I'm not sure whether that's just me, but
let's talk about your feeling about dumps.
Yes, exactly. That's right.
All right. So what's your next one?
I've got an article by Jason Brownlee from his excellent Super Fast Python site, which is about parallelism in Python. The article is called Async IO Event Loop in Separate Thread. We've talked about Brownlee's stuff before. He's come up in episodes 139 and 204. To understand the article, you need to first grep Python's async IO. Generally speaking, in any language, concurrency is hard. Python then makes that slightly more complicated because of the GIL. Concurrency in computers has a muddled history, and so you get this mix ranging from let the operating system do all of it to we can't trust the operating system, we must do it ourselves.
Yeah.
And so there are two broad categories of parallelism: process and threads. Processes are heavier, are the original forms of parallelism, and used to be the only way of using multiple CPUs. Threads are lighter weight, run inside of processes, and were meant as a compromise when processes were considered too heavy. Processes do not share memory, and so there's the added overhead to get two parallel processes to talk to each other. Threads, on the other hand, are in the same process and share memory, which is part of what makes them lighter. This is also what makes them dangerous, as you can create race conditions when two threads fight over the same resource. So there are two variations on threads, regular threads and green threads. As different operating systems came to the threading party at different times, programming languages that were cross-platform started implementing threading capabilities as part of the language. Those are the green threads. So the operating system's not necessarily aware of them. It's just scheduling a process, and then the programming language is doing the threading underneath. And if all that's not complicated enough, Python supports both processes, threads, and green threads. And their variation on green threads is the async IO library. So that's a bit of an oversimplification, and there's probably someone screaming at the at their source of podcasts now, but it's good enough between friends. Async IO uses a concept called a coroutine. It's a cooperative concurrency mechanism, and essentially it's where one part of the system can say, I don't need the CPU right now, I'm waiting for something, freeing the CPU up for some other coroutine. So fundamentally, this is what threading is for, with the added mechanism of the code being in control of when the thread gives up the CPU. All right, so if you're with me so far, like I said, concurrency is hard. By default, the async IO event loop, that's the thing where the coroutine runs, executes in your process on the main thread. So if you don't do anything, your main thread is the only thread in your process, and then the coroutines are run on that. So now that I've babbled for a bit, I can finally get to Jason's article, not Jason's article. And he's talking about the fact that async IO event loop doesn't have to be on the main thread. You can stick it on a different thread if you want to. So let's start out with the why. He gives three reasons. Reason number one is integrating synchronous code with async IO. So if you've already got a bunch of code that is used to running on the main thread, and then you want to bolt on some async IO, that sometimes can be problematic. So by moving the event loop to a separate thread, this can be helpful for applications that need to operate in both the synchronous and asynchronous modes. Reason two is kind of a subset of reason one, which is having to do with blocking IO. So what threads and coroutines do well is free up the CPU when they're waiting on IO. So say you're doing a call to the internet that in comparison to your CPU is quite slow. So if you're waiting for a response from the internet, say loading a web page, your CPU could end up waiting for hundreds of thousands, if not millions of operations. So a cooperative multitasking mechanism gives the CPU up to someone else so that they can work while you're waiting on that IO. If you've already got code that expects to operate in a synchronous fashion to block for IO, it can get kind of gnarly to rewrite it for asynchronous. So instead, if you want to mix and match having both the IO blocking stuff on one thread and in sync on another, then again, this coroutines on a separate thread thing might help you. And then reason three is kind of my favorite, which is isolation and recovery. By putting the async IO stuff on a separate thread, you can then use the main thread to monitor the async IO stuff. And this can lead to cleaner shutdowns if things are misbehaving, or if you need to restart crashed coroutines. So for long running programs, this kind of architecture can mean a lot more stability, and it allows you to sort of auto recover a little better. So with the why out of the way, the article then goes on to give detailed examples on how to get async IO going on another thread, as well as how to deal with complications like passing arguments. So Jason's content is great. He's got tons of stuff on concurrency on the site. So if you want to learn more about this thorny bit of Python, this article and his site are great places to dig into this stuff.
Cool. Yeah, we got a few resources also. If people are interested, you have a course that we could talk a little bit about.
Yes. And more coming, actually.
Yeah. We might have something for talking Gil soon. So
yes, which is all the why concurrency. Oh God, this is why lock.
Here we are. Yeah. This week, I want to shine a spotlight on another Real Python video course. It's the course that Christopher was speaking about earlier. And if you'd like to practice grouping data in pandas across multiple data sets, this is a great place to start. The course is titled Pandas Group By, Grouping Real-World Data in Python, and it's based on a tutorial by Brad Solomon. And in the video course, Mr. Trudeau takes you through how to use Pandas Group By operations on real-world data, how the split, apply, combine chain of operations works, how you decompose the split, apply, combine chain into steps, how to derive groupings with custom lambdas functions. Plus, if you haven't worked with pandas before, the course has a refresher on the main concepts to get you started. Real Python video courses are broken into easily consumable sections, and where needed, include code examples for the techniques shown. All lessons have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the enhanced search tool on realpython.com. So we do have a discussion topic. We had this article and it's huge. So we decided to just take a couple key notes on it that we can talk about for instead of 5 hours, we could just maybe discuss it for a little while. So
yes, and we're going to recycle it. We'll use other parts of it later. So we'll eat the entire buffalo. So yeah, the article's by Vadim Kravchenko, and it's called "Habits of Great Software Engineers." And as you said, there's a lot in here. He's got 8 habits, and then he divides it into 12 parts. I'm still not clear how that happened. We're going to focus on 2 of those. The first habit that we're going to talk about is called knowing the why. And in short, this is the idea of understanding the design decisions in the tools that you're using. Rather than just, say, blindly using a tool, understanding it a bit under the covers gives you a better chance of using the tool correctly. He does say this can be in moderation. If you're a front-end dev, you don't have to learn assembly. But knowing how and why CSS is rendered will make you better at your job. And then the second habit, which feels somewhat related to me, is called thinking in systems. And although at times you need to focus solely on the code that's in front of you, you should occasionally step back and look at the bigger picture. Understanding how the parts you're working on interact with other parts in the system tends to make you better at writing your parts and making sure that they fit the big picture properly. So, thoughts? What did you think?
I wanted to discuss this a little bit with you before we started today, just to make sure that my thoughts were kind of in the same kind of ballpark of what we were kind of digging into. And I mentioned to you that I think it's probably pretty obvious to most people that listen to the show that I'm a very curious person. And so I really like knowing the parts of the system. I feel like it's always been a way to sort of shortcut lots of sort of confusion. Like, who do I ask about something and understand things? One of the things that I enjoyed about a couple jobs that I had that were somewhat corporate is that they would occasionally have a shadowing period where they would take you to different departments and let you talk to them and see what they did. And obviously there are people that are not curious, that are not going to ask that person any questions. And then there's people like me that will, take up half their day with like, why do you do it this way? And so I'm definitely one of those people that want to know the why. I feel it's crucial. If you're not able to answer a question and know where to take that question next. It's like it's just frustrating. All these assumptions start to be made, and then this weird kind of barriers start to be built up in it. And I feel like it's crucial. Like one of the things he mentions in there is this idea of bridging gaps. And so I feel like that really falls into that kind of category. But also innovation, this idea of like, well, who can help you
Yes.
and find out, who can help to do these different things. And you've often mentioned about coming in as a consultant, basically being the voice that says to a non-communicative, like management culture or what have you, that isn't asking those questions across the system, and the internal team saying, well, I do this and it's not working with this or whatever, and then having to like raise that concern. And I always, that drove me crazy in corporate environments, because I've only, was only in a handful of them, but I would see it and just be like, well, can't we just talk about this right now and between us, instead of involving this other person? And you've explained it a couple times, like the sort of clout that is brought in with it.
Yeah.
So I don't know, that's some of mine, like knowing the why. Like I'm just a super curious person, and I'm very interested in, he mentions kind of the front end to back end kind of web development sort of application, but I've worked in banks and mortgage systems, and there's lots of different people in this sort of chain of doing something. If you've ever tried to get a mortgage, there's the whole like initial, like just filling out the application and getting that stuff in. And then there's the person who's going to find all of your financial history. Then there's the person who's going to underwrite it and say, yes, this is, and so forth. And all of that very often involved lots of technology and lots of parts. And a lot of them use the exact same software, but they use different parts of it. And so that was a job I had to do, which was like I was recreating all these reports of this stuff. So,
or even don't use the same software, which is why when you get passed from one to the other, you get asked the same question 4 times because, I don't have that information. And
yeah. So it's just interesting, like I find systems fascinating, and I get frustrated when there's just a simple reason, which is just, we just don't communicate with each other.
Yeah. Well, it happens at the technological level as well. So that there was a pension that I was working for, and the folks that I was working with were sort of the report people.
Yeah.
And so the traders who were actually managing the pension and using the stock to make the pension holders money were constantly looking at all these different kinds of reports, how things were operating, different pieces. And these reports were often coming out of many different data feeds. So you've got a stock feed, you've got a bond feed, they're coming from, you've got the Canadian feeds, you've got the American feeds, all the rest of that kind of stuff. So there's all this amalgamation of data that's happening. Well, oftentimes the feeds are being managed by different departments. And if each one of those departments makes a different decision about how to handle when data is bad or empty, well, that floats downhill, because one of the departments might go, we'll just average the two numbers, yesterday's data or last hour's data and the next hour's data, and we'll fill it in by smoothing the curve.
Right.
And then somebody else drops in a null, not available marker or something like that. Well,
right. So maybe a value's rendered as 0 or something.
Yeah. And now all of a sudden you've got the report having to deal with this, and systems crashing because they write it based on the expectation that it's smoothing. And then, Tuesday comes along and one of those NAs pops up, and then all of a sudden your system falls over and everybody blames you because, why is it's your report system that fell over? And meanwhile, it's, 3 levels behind you on the data pipeline that actually made this decision. Right. And so if not only just the individual, but if the organizations don't occasionally step back and go, wait a second, how does this part that I'm working on fit into the bigger picture? It can run into sort of problems. To sort of loop it back to sort of the why aspect there, the knowing the why.
Yeah.
There's sort of 2 parts to this. There's in the article, he concentrates a little bit sort of on the business level. So, why is this component necessary?
Yeah.
If the component fails, how will it impact other systems? But there's also there's the business level of, why are we doing this? Folks who do requirements, sometimes their title is BA, stands for business analyst. They're the folks who actually try to figure out what the system's going to do. They talk to the business, write up some document, hand it over to the developers. In the agile space, that's a product owner. And there was a BA that I used to work with, and she used to love telling this story where she was at this credit card company in their fraud department. What the fraud people do is they look at transactions as they go through, and every day they're looking at the transactions and going, oh, we need to follow up on this transaction, or don't, that one's fine, that some of that kind of stuff.
Finding the outliers and such.
Yeah, exactly. And some of this is done by AI and everything, but some stuff still needs to be reviewed by a human being. So they had this new project they wanted where they were going to archive some of the transactions into a separate system. So now we've got, instead of having one computing system, we've now got two computing systems. So not one source of truth, two sources of truth. So she starts going, okay, and well, when you run a report, does it run across both systems, or are they two different reports? Oh, no, it's got to run across both systems. Oh, okay, and can you move transactions back and forth through? And she was just going through this, and the more questions she asked, just the bigger and worse this project was getting. Like, this was going from this started to, M was the beginning of the dollar signs were M's to get this project going. Yeah. And she finally stepped back and went, wait a second. Why do you need this? And then they described their problem. And their problem was that there's more transactions than fill on a screen. And they need to look at the most recent transactions first. And the system put the least recent transactions first. What they needed was sort. They needed to be able to push the button and say, put the newest stuff at the top. And as you can imagine, delivering sort is significantly cheaper than, hey, let's have a complete duplication of this system, right? So, and this is something that, this is a BA story, but developers fall into this all the time. The BA or the business or whoever says, hey, give me X. And instead of taking a second going, give me the context. Why do you need X?
Yeah.
And providing a solution that actually solves the problem rather than doing exactly what you're told, you end up in this space where you gave them what they asked for, and that doesn't actually solve their problem. It can actually make this situation worse, right?
Yeah. It's a sales thing. I mean, I did sales for quite a while, and the whole qualifying thing, it's like, well, why do you need a computer?
Yes.
I was sold computers for a while, and it's like, well, I was told to buy this. And it's like, okay, well, what are you going to use it for?
Yep.
Where are you going to use it? Does it need to be portable? Like, there's like so many questions.
Yeah.
And I enjoyed that process. I think a lot of salespeople feel like it was invasive or something else. It's like, no, this is like, I'm trying to solve this person's needs, and they love that you're doing that. They want to make sure.
And it makes for a happier client.
Yeah.
I used to be on a firefighting team where we'd come in to try and help rescue projects. And frequently, one of the first things we had to do was evaluate what hardware had been bought. And the client, by the time we were on an engagement, the client was already angry. And then for the first thing for us to do after we showed up, after being there for a week, was, oh, by the way, you need another $3 million in hardware because they didn't spec it out right the first time. And it just tends to make them angrier, right? And it's because somebody went, oh, you said you need this, so you need two of these and one of those, and that's it. And then we come in and go, wait a second, you also said you need these things and you wanted redundancy. There's no redundancy in this system. You'll need more servers. The why is really, really fundamental, right? And I think it's a nature of the developers that we get down in the weeds, and it's very easy to sort of stay there. But every once in a while, you got to stand up and go, oh, wait a second, how does this fit? What problem are we trying to solve?
Yeah.
Because if you're not, then you're not providing value. And, that's really what we're supposed to be there for.
Yeah.
And just to bring this back full circle, you're talking about, you're the guy who's in there, air quotes, wasting everyone's time asking questions. It's one of the things I look for when I hire, right? Because if they aren't interested in how things work, then I'm like, oh, well, yeah, you're probably not going to be a problem solver. And fundamentally, that's what we're always doing, right? This is what we're getting paid for, is we're trying to solve problems.
Yeah, it's the lack of curiosity is baffling to me. I don't understand it. I don't want it to impede somebody's flow. I definitely can understand when this is okay, this is not a good time to ask the question. The fire needs to be put out now.
Sure. Yeah.
Why did it get started? It's that's not important, but where we need to move forward. But I'm definitely the person who wants to be at that, the postmortem of whatever. I want to be there, and I don't want to cast blame. I just want to not have it happen again. And try to figure out stuff. And one of the things that that kind of got into the next point of the thinking in systems part, which all of this feels very, very like, integrated. It is all about systems and, why is the system built this way and so forth. That I thought was interesting is that I feel this focus, especially by developers, to make sure that, hey, I got tests, I have unit tests, my software works, and so forth. And the reluctance sometimes to look at an end-to-end test, a way of like, well, how do we get across the whole thing? Because the connection points are always going to be, I don't know, can be very, very creaky for a variety of reasons. And it's a harder thing to do. We kind of talked a little bit before we started about this idea of like, okay, well, how can you even kind of control that? Or as you go into maybe a third party system, like that was one of the things I had to do with the mortgages, that there were these external sort of validation things that we needed to do, these sort of regulations that needed to be set and so forth. Like I've worked in compliance, I've worked in risk management, and I've worked in these kind of odd situations where, okay, well, we need to think about these things, about like how that's going to get there. And that kind of complication is something that I feel like a lot of people feel like, okay, well, I don't want to have that be part of my department. It's like, I want to just worry about the code I'm writing.
Well, some of it can come out of just sort of self-preservation as well, right? So like if you're,
right,
unless the system has been designed with testing in mind,
right,
even if you're well-behaved and you're building all the tests for your part, where your part bumps up against everybody else's part starts to become the challenge, right? And I've worked with many, many clients where their test data was, oh, well, we just grab whatever was in production last week and then we pull it in and run the tests. I'm like, well, then how can you run your tests if the data's changing? Oh, well, we go through and we look for a current situation in the production data that matches the test and manually enter that information, right? And if you don't have tests, don't get me wrong, that's better than nothing. But to have a system where you've actually thought about this part talks to that part and how do we put the parts in test and how do they talk to each other? I'd like to say that's a more modern approach, but it's been around for 30 years. We just don't seem to be doing it consistently on larger engagements. So,
yeah, sort of this QA kind of thing, that's in manufacturing or some areas of software, where you think about video games and so forth. They have like, people testing and trying to figure out like, wow, I never thought someone would do that. And get stuck and so forth,
And it's not just software, like you see it in manufacturing, right? So Lean, which comes out of Toyota, has this concept of just-in-time manufacturing. And that's the idea. You don't keep a lot of stuff in the warehouse. You just use, you buy the things as you need them. And the justification behind this is it means you fail more frequently, and that means you find the source of the failure and fix it. And when Lean got adapted in North America, what ended up happening was they were lean within the factory. And that's better than nothing, but the suppliers to the factory weren't. And so this is kind of the equivalent, right? You're not looking at the chain. Whereas Toyota, and they're big enough they can do this, they just won't work with you. Like, oh, you're not lean? You can't be one of our suppliers.
You're not going to have a constant stream of stuff to us. Yeah.
And when they designed the Prius and knew that they were going to need batteries for it, they couldn't find a battery company that would be compliant with how they did things. So they went and partnered with a battery company and created a new one, which was lean, because their entire framework needs to be there, right? But organizations, particularly large organizations, being that aware of systems thinking and how things flow and all those pieces and trying to be cognizant of it, they're very rare. They're very, very rare.
Yeah. We've talked about a few times about individuals inside of the larger, pipeline or whatever, potentially pulling the cord, which was like the thing from the sort of Japanese.
Yep, that's very much
places saying, yeah, exactly. Just saying like, hey, this is broken. We need to fix it right now. We need to stop and move forward. And he mentions in the article an FTX engineer and them just not questioning, well, why are we allowing accounts to go negative?
Yeah.
And I have something to add on top of that, which is like, why is there a random number generator in our system to show anything to do with funds? Like somebody should have been pulling a cord, but, or wasn't allowed to. So, but anyway, it's interesting to think about. Well, cool. So I think that takes us into projects.
Sure.
I have a fun project this week. I think people know that I think both of us are known for liking video games and kind of dabbling with it inside of Python. So this is a library called Pixel. It's Pyxel, and it's a retro game engine for Python. And it's a project by Akashi Kitao, and it has over 14,000 stars on GitHub, which is pretty impressive. And I was just, wow, this is a cool project. It has very simple specifications that are inspired by retro gaming consoles. It has 16 colors, that can be displayed at once, and 4 sounds can be played back at a time. So the idea is that, the music and so forth is very, very retro in design. There's a few different, engines that it was inspired by. The results are pretty impressive, and also the sort of distribution of it. It has a bit of Rust under the hood. The project seems to have some connections as far as distribution using Wasm and Pyodide. So not only is it a library for making these retro games, but it includes a lot of the tools for creating the music and the sprites and things that you would do in the game. When you install it on a Mac, they suggest you using pipx. I think that's partly to install these tools that can then be run at the command line. It shows in the installation of just using pip on Windows and Linux, so I'm not sure. I haven't used those for playing with it. I did play with the music creator, which is it's kind of cool. It's interesting to write music in this sort of, I don't know if anybody, you got to be old enough to know what a tracker is, but creating music in that kind of style where you're like kind of clicking on something and putting notes into it. There are a ton of examples in the repo, which I think is probably one of the most useful things about it. Probably one of the hardest things is how do you use it? They have this whole documentation section, just how to use, and it's names of APIs. The way it's kind of written out is a little kind of clunky. So I feel like it's going to be a project that if you're interested in doing this, you're going to probably spend more time looking at examples to get a handle on the best practices, as opposed to looking at documentation. There's a FAQ, and it says that there have been books written, but they're in Japanese. I think 2, and none of them are by this particular developer. There is plans for an English version. So he actually sets forward and says, okay, if you'd like to learn it, there's a suggested that you specifically use these examples. Okay, start with example 1, then do example 5, then do example 3, then do example 4, and then 2. Just in that order. So just be aware that it's an interesting order to kind of follow there. I love one of these other examples that's in there, which is it's for kind of playing with the waveforms and synthesis. It actually has a piece of music playing, and then you can kind of draw to create different waveforms, and in real time, it's looping the music around. So you can hear it maybe change to the shape of more like a square wave or a sine wave or a triangle. It's pretty cool. I wish I had more time to play with this week, but I will definitely be back. Pixel. All right. What's your project?
I've got a project by Michael Williamson, and it's called Python Vendorize. The act of vendoring is to take a third-party library and copy its contents into your source tree. This is done for a variety of reasons, including making small tweaks to the code because you don't like how it behaves, fixing bugs, that kind of stuff, building a package for systems that don't have easy access to installation tools or even the net. So you have to bundle things together, or to compensate for, say, the lack of stability in a package. Vendoring is a language agnostic thing. I did a bit of digging, and it looks like vendor first got verbified in Ruby in 2007. Some languages actually even come with tools that do this. So what Michael's tool does for you is to manage the act of vendoring pure Python libraries. So it takes a TOML file to specify what to vendor, and then manages things like the sub-dependencies of those packages that you consume, putting them all together. One of the strengths of this tool is it sticks the vendored stuff in a new package, in a new module, which is probably the primary reason why you might want to do vendoring in Python. So let's say you had 2 libraries and they have conflicting version dependencies. You can vendorize one of them, sticking all of them underneath the vendor package, thus isolating the problem. So this isn't something most people are going to do, But if you do run into this problem, having a tool do it for you rather than having to deal with it all manually is fantastic. And helps, prevent you accidentally missing a dependency. So if this is something that might solve a problem for you, you should check it out. Python Vendorize.
All right. Well, thanks again for bringing all these news items, these topics and discussions and projects again from PyCoders, Chris.
Always fun to be here.
All right. Talk to you soon. And don't forget, this episode was brought to you by Mailtrap, an email delivery platform that developers love. Try it out for free at mailtrap.io. I want to thank Christopher Trudeau for coming on the show again. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and look forward to talking to you soon.